Hey everybody, welcome back. Week 3. Thought I'd do the same kind of thing this week and do a little crash course with forces. This was chapter 4, and this was only chapter 4. If you remember, it was a pretty big chunk of stuff. Just wrote out the topics. Here are the topics that we covered, just to get you thinking about these again. But we did resolution of forces, which basically was just us realizing that forces were vectors, and we could do all that triangle stuff with them. From there, we did Newton's laws, so definitely look over those, be able to identify what's what. We did free body diagrams, which were a little bit more involved, and we're going to go into some detail with this video on those. And then we complicated those with friction, and we ended up with force systems. If you remember, the AP folks will use that word system to describe anything that has more than one object. And so they use the word body here for just one object, but then they use the word system for multiple objects. So anyway, we'll take a quick spin through some of these things and get you thinking about the right things before you start in on the problems and other stuff for this week. The nice thing is basically just two equations in this chapter. You had F equals ma, which was Newton's second law, which we used the heck out of. It's all over the place. And then we had the friction equation here. So that was it. A little more simplified versus last week when we had all the motion equations and the different variables and things like that. It's more of the setup and the conceptual setup for these problems that are tricky. Not really, using these equations obviously are pretty easy to do. But anyway, those are the two equations. The free body diagrams, if you remember these, you might need to take another spin through, draw these back out. We labeled these, if you remember. We called this diagram number 1, and this was the most simplistic when things are sitting on a horizontal surface. Remember, in terms of finding FG, all you have to do is just take mass in kilograms and multiply that by 9.8. Or if you were given FG, which could also be called the weight, all you'd have to do is take FG and divide that by 9.8, and you could get the mass. So we did that a lot. I'm assuming you guys remember that, but just in case, that's a pretty important thing to be able to do in these diagrams. In this diagram, remember FG and FN are equal. And that's because the object's not sinking down into the ground and it's not floating up into the air. And then there's also special case scenarios in these diagrams if it tells you constant velocity. That's kind of a big thing. So like in this diagram, if they tell you that this object's moving at a constant velocity, then FA would equal FF. So that's all details. It's all in your notes. Look over. We kind of wrote all that stuff out. This is what we call diagram number 2. Complicated because the applied force is at an angle now. And so you have to do the vector stuff here. You have to break down the x and the y components for this one. But yeah, review that. Also, remember that FN's a little trickier to get here because you have 2 upward forces. And the key was just realizing that the 2 upward forces, so Fn and F up, would equal the downward force, which is Fg. And so that gave you a way to solve for those things. All right, and diagram, what we call diagram number 3. This one was an incline, so no longer a horizontal surface. So this is the way it draws out. Remember FG, always pointing straight down. That's usually a starting point on some of these so that you can begin to establish your triangle down here. And then once you get your triangle, you can solve for normal force, probably just using cosine. And then FA, remember FA, if you solve for this side of your triangle down here, so this bottom part, then that's the exact same as up here. And we went through and we proved all that, but there's no need for that now. But this would be the same as your applied force. Same kind of things here. If you're moving at a constant velocity, then these 2 forces would be equal, FA and FF. If this thing were sliding down the incline, then and accelerating, then your applied force would be greater than your frictional force, that sort of stuff. So yeah, I think that takes care of that. On the AP test, which this is, definitely a topic they could hit. If you have to draw one of these, remember they do that dot thing. So they'll give you the dot. I'm trying to think how they'll do this with the new format. It may be more of a labeling sort of thing, but they give you a dot, and then from that dot you would label the forces that are actually acting on the object. Remember to touch the dot. We talked about that. And make sure everything points in the right direction. The length of the line can be representative of the amount of force that's present. So if you had like this and this, you could tell that the applied force was greater than the frictional force and that this thing would be accelerating. So I guess I should finish that off and put normal force in there. So anyway, there's that. Review those. The only other thing I wanted to show you just briefly, and then you guys can look at old worksheets and work through a couple problems on the review sheet, is the force system stuff. If you remember, this was one of the ones we did where the object is sitting on horizontal surface. There's a pulley, and then this thing, I guess I could draw the ground in here, is above the ground, and this pulling down makes this go across the tabletop. So if you're solving for like acceleration, you've got the FG of this working against this object that's up here to see if it's going to accelerate. So you probably need to find like a frictional force that's up here and kind of go from there. The Atwood machines, or the elevator, that's this one. Sometimes you'll see them called this. I think they'd use the terminology elevator too, but where you have like a weight and a counterweight sort of setup. Remember on this one, it's just basically a battle of FG versus FG in terms of finding the acceleration of the system, and the bigger one would win out. Just the way I've got this drawn, this one's probably got more mass, so this system will move this way, but this FG is going to work against this one. So you're going to have to find a net force. So plug in F net, set that equal to MA. And in this case, that mass is equal to the total mass of the system. So add those two things up, plug it in there, and then find your net force by subtracting these two guys and solve for acceleration. So I think that's about it. In terms of this being a quick crash course, that'll get you thinking about the right things, jump in, work some of the problems. Hope you guys are doing all right, keeping yourselves entertained. Email me if you guys have questions, I'll help out. See you soon.